Well, good morning, good afternoon, good evening to wherever you may be across the world. Thanks so much for joining us again live here today for Serverless Office Hours, streaming on AWS Twitch and Serverless Land YouTube channel. My name's Julian Wood. I'm a developer advocate for serverless here at AWS. And this week is Step Functions. And we are super happy, or I'm super happy, to be joined by some extra gurus, Prashanth and Sandeep. Prashanth, Sandeep, how are you?
We're doing great, Julian.
Excellent.
Doing
Well,
great.
I know it's 10:30 where you are in the evening, which is in Bengaluru in India. I visited, well, when it was actually Bangalore, too many years ago. And I have a funny story because we'd taken a train overnight and we arrived in what was then Bangalore in the early morning, and we needed to check some emails and sort some things out. And we couldn't find an open internet cafe. And I remember talking to my now wife going, we are in Bangalore. This is the center of the IT world, or certainly within India. We can't find an open internet cafe. So after that, we found an internet cafe. It was all, we had a great time in what is now Bengaluru. And so, yeah, that was cool. So I'm so glad you've joined us today. It's late for you, 10:30 at night. So for the people joining in the sort of western part of the US, and it's 10 o'clock in the morning, we're literally spanning the globe today in a special episode. But just to do some more introductions for Prashanth and Sandeep, they are part of Anstack, which is a serverless-focused technology services company. Prashanth on his bio says he's a generalist and simplifier, and AWS Serverless Hero to boot as well. I really like that. A generalist and a simplifier. That's something I aspire to. I'm not a sort of hardcore either coder or engineer or whatever. I like to think my whole IT career has been about generalizing things, because I think it's important, particularly when you're building serverless applications, when you're doing a whole bunch of different things, and simplifying in my book is always an awesome thing. So yeah, Prashanth, just tell us a little bit about you, and yeah, you are, I know you're the co-founder of Anstack, but yeah, tell us a little bit about you.
Hi, Julian. It's a pleasure to be on this show. I always don't miss any of the episodes. I look forward to each and every week's, what's happening in the Serverless Office Hours. And there's always some new takeaway for me out of SOH. So I always look forward to it. About myself, co-founder and CTO of AntStack, like you already mentioned, which is a serverless-focused consulting and development firm. And before AntStack, I was an entrepreneur again. I was running an e-commerce startup, and there, I come from the background of traditional. I don't know if that's the right word to use. AWS stack, which is EC2 ELP stack, running Rails applications on EC2 ELP stack. And between StyleTag and Anstack, I was consulting independently for startups, and also Lambda happened during that time. And I was so kicked about serverless during that period, because I come from the running infrastructure and I knew the pains of doing so. And when Lambda came about, I was like jumping on it. I'm like, wow, this is really, really cool. We don't need to worry about so many other aspects of running the infrastructure, and just focus on our business logic and focus on building our business. So I was really kicked about it. And that's when I kind of became part of AWS community in Bengaluru along with Jeevan. And before pandemic, which was year 2019, I did a tour of community day tour across India. Like, I visited so many cities and spoke about serverless, wanted to spread the word about serverless across the country. And after that, AWS listed me for being a Serverless Hero. So that's kind of the journey, like coming from typical EC2 ELP stack to serverless, and why I enjoy doing serverless so much.
Excellent. Well, thank you for letting us know. That's a great and common story, and we love that you are spreading the serverless love in India. And Sandeep, you title yourself as a full stack serverless developer. Does that mean from a full stack developer, is a full stack serverless developer even more of the stack or even less of the stack, or what do you think about what is a full stack serverless developer? And yeah, how have you come to join Prashanth in Anstack? And yeah, what have you been doing before?
Yeah. So hi, Julian. My name is Sandeep. So I've been working in Anstack for about a year now. So before that, like my journey started as infrastructure automation for serverless, and then that slowly moved on into backend development. Then it moved on into front end development too. And why Anstack? Because Anstack is one of the companies that shares the love for serverless. So when I saw Anstack is doing serverless and they're from the same town, I'm like, I have to be there. And then of course the leadership, Prashanth and Jeevan, after both of them are serverless heroes. So that was one of the main inspirations to join Anstack, and definitely the love for serverless.
Well, they're good to have you and been talking nice things about your boss on our streaming platform. So hopefully that means that's going to be a good bonus for you coming up when you ask. Cheeky of me to say, I know. Yeah, just looking back, before we head on to the awesome stuff that Prashanth and Sandeep are going to be talking about. Last week, if you missed the show, it was talking about AWS Lambda, and that was Eric Johnson and James Bezic. And this was about the GIF generator. And there's a direct link with the show this week because James was showing off a way to use Lambda for parallel processing. And basically what it does is it's a video that you input, and a video could be a movie, it could be something, and it generates GIFs for every 30 seconds of it. You run it on pull in the movie once and run it, and it takes literally, I think it was 10 minutes or maybe even 20 minutes to generate 30-second GIFs for an entire hour and a half, I think it was, movie. James has built an excellent way of using AWS Lambda to do it, obviously parallelizing that workload out, and took it down to something like 10 seconds. I think it was 10 or 20 seconds. So a really good use case for using Lambda as a sort of parallel supercomputer, I'm going to say. And that ties directly into this week because Sandeep and Prashanth have got another way to think about doing media conversions using step functions. So definitely go and look at the video from last week on youtube.com/serverlessland. And yeah, there are many ways to do serverless. So James has got a great way to do that. And today we're going to discover even more. Just quickly looking back at what is new in AWS serverless. To be honest, there hasn't been a huge much over the last week. Some of the things here in the list, like Python 3.9 support, and the dynamic partition for Kinesis are from a few weeks back, but really cool just to have up on the list. The main one from last week is Amplify. This has some command hooks to execute custom scripts when you're running the Amplify CLI commands. So Amplify CLI allows you to interact with the Amplify hosting. And what you can do is you can do some post-push or pre-push or some other commands. And this would probably be useful if you want to hook it up into your CI/CD pipeline or things like that. Just gives you a bit more flexibility when you are building front-end applications and back-end parts with Amplify. In terms of serverless blog posts, the GIF generator, which I just spoke about, was James. He's got the part 2 is now out today, or I think it was yesterday. So that goes into all the code, and you can see exactly how it was all done, which James spoke about last week on Serverless Office Hours. My series on building well-architected serverless applications has drawn to a close. I'll cover that shortly. James also has a previous post from a week or so ago, which is really cool, using a Saga orchestration pattern. And of course, Step Functions works very well with the Saga orchestration, which is all about rolling back changes if something goes wrong. So if you're interested in Step Functions, look at that. And I always love this one from Mark Sales, which is about increasing the performance of Java Lambda applications using tiered compilation. Lots of people using Java, and there are really some good and easy tips and tricks to use to be able to get even more from your Java applications. Please don't forget, on serverlessland.com, there's cores.serverlessland.com. If you use API Gateway, and I'm sure you love and understand everything about cores, I know that's unlikely to be true because it's difficult and tough. Well, Eric Johnson, co-host of the show, has put together this really awesome tool, the API Gateway Cores Configurator, where you just go and fill in a few kind of things, and it's really going to help you build up what you need in your SAM templates, and also what you need to put in your REST API resources and in your Lambda functions to be able to make cores far less painful. So please have a look at that. If you're getting started with serverless, Ben Smith has had a whole series out. This focuses on developers in your IDE, learning about serverless and understanding what business logic is and the front door and how that maps to different AWS services. This is my series, which I wrapped up finally last week. I think it's 21 blog posts, which goes over the whole gamut of building best practices in your serverless application. It's all built on the serverless lens of the well-architected framework. So if you're building well-architected applications, particularly with serverless, have a look at these. And there's some good explanations, some good deep dives and some kind of things, and just an explanation of all the questions that the well-architected tool will ask you about your best practices for Lambda. Serverless patterns are always cool to look at and keep in the back of your mind. They've been continually being updated. These are SAM and CDK snippets of code that you can use to build the building blocks between applications. So if you're linking, for instance, Step Functions and Lambda, or you're linking API Gateway and DynamoDB, there are a whole bunch of them. I've even lost count. It says 26 over there, but there are way more. I know there are. And it's open source as well, so you can contribute your own. And this is a really great way. I've been building for the past few weeks. I go to the serverless patterns to go and grab the snippets of code. It's much easier than hunting around elsewhere on the interwebs. So with not much more to talk about, please, I'm more than happy to hand over now to Prashanth, who's going to be talking first. It's Step Functions Week. And yeah, as I mentioned before, we're going to be talking about near real-time media conversion. So Prashanth, I'd love to know first just a little bit about Anstack. I'm guessing, and I haven't spoken to you about this, is, we've got pets and cattles, and maybe we've got ant, and these are small little functions, and that's why serverless is cool, but I could be completely wrong. So I'll hand over to you, and you can explain the real-time media conversion and a bit about Anstack if you would like.
So the whole the concept about naming our company Anstack was like, if you look at a Lambda function, it's a tiny compute a box you could consider like unit. And when you look at the Lambda function alone, you think, okay, what I can do? It has so many limitations, and it can only do so much, and so on. But if you put it in a bunch, then it becomes really, really powerful. You can pretty much do anything you want to do. It can be very powerful architecture which can execute anything you want to do. So similar to ants, if you look at an ant at a singular level, it's a very tiny ant, and it cannot do much. But as a whole, as a colony, they are actually quite powerful. And on Earth, a lot of vegetation and everything depends on ants being there in their territory and so on. So that's the inspiration for us to name company Anstack. So we are really super focused on serverless and serverless architecture. We have done a lot of implementations fully on serverless. We like one which we are putting across in this talk, as well as we have done e-commerce, fleet management, we have done logistics, we have done media streaming, we have done media distribution. So we have done a lot of complex workflows on serverless, and it's been a really wonderful journey for us to showcase that it is possible to be fully serverless in your architecture and achieve pretty much anything you want to achieve.
So just picking up on your point there, when you're saying to be fully serverless, what is the reason for that as a goal? Because many companies may be sitting there thinking, going, well, I don't necessarily have a goal to be fully serverless, or I have a lot of EC2 instances, or I'm running containers, or maybe on-prem, or this kind of thing. How are you advising clients to say, well, what is the benefit of going fully serverless? Maybe when people are thinking, well, I'll just use it for the rest of my stack. How would you advise people about that?
So our main focus area in terms of whenever we are talking to customers is explaining them the management model, responsibility model between the cloud and the technology which we use. And we generally explain them, the responsibility model is more with the cloud providers such as AWS when we are using serverless. If you can go ahead and spin up a RabbitMQ cluster and in a container and run your own queue. But hey, there is SQS. You can just use it, and it costs peanuts, and you don't have the headache of running that infrastructure. So, and you can be very, very small in terms of the team requirement to execute things on serverless compared to having to hire a lot of different people with different expertise. And these days, talent is becoming a big challenge to get. So that is one of the major focus area which we kind of pitch to our customers. The second thing is the ability to drill down the cost per transaction in serverless is just crazy, because in any other architecture, you kind of it's very hard to figure out what will be your cost per transaction because it's very hard to articulate that information when you are running, a lot of servers, and you don't know how many servers you exactly need per request and so on. But in case of serverless, you can actually trace a transaction at every component level and figure out what would it cost me to serve one particular transaction. And it helps to pitch to our customers saying, hey, you know what, if you are not gaining much of traction today, you are not going to be paying crazy amount of bills to AWS. You are only going to pay for whatever you are consuming. And tomorrow suddenly your product starts to work, and you are doing a lot of you onboard a lot of customers, and you are seeing a lot of transactions happening on the system. Then your bill is going to be directly proportional to your scale. It's not that you need to invest heavily in advance to get the infrastructure working for you. So these are the
Excellent.
aspects we try to pitch to our customers.
Excellent. Thank you very much. And first question as well. A comment has come in from Zach Jones Noel. Brilliantly put across. Yay, go serverless. So thank Zach Jones Noel for the comment as well. And yes, we are live. Remember, if you have any questions or comments for myself or our lovely team over here, please send them on, and we'd be happy to answer your questions. So, Prashanth and Sandeep, what are you wanting to show us today?
So today we wanted to showcase one of the capabilities we built for one of our clients using step functions, lambda functions, and batch functions. And it's a very complex workload which we wanted to showcase. It is possible to do using serverless. The use case is for a media streaming company in India, which would want. They generally have a raw video format, and they need to optimize it for different aspect ratios, different devices, different resolutions, and so on. So the need was to keep all these different resolutions ready to be streamed depending on the bandwidth and the device and different set of rules which they had. So the main aspect which we want to showcase today is how we are doing the conversion. So if you could share the screen, then we can probably walk through the how the whole thing flows in the system, and then probably get into system architecture and dig deep into how it is actually functioning. So we start with the raw studio file, which is a video file, and we split it into two parts. One is we split audio and the video out of it. So we have raw audio and raw video coming out of it. Why we do this is because a lot of different video formats use the same audio format. So there is reusability aspect in the audio conversion. So we don't need to convert audio the same amount of times we convert the video. So we convert the audio into different formats and keep that ready. And then the raw video, since the video files are raw, it's going to be very large. I'm talking about 50 gigs, 100 gigs kind of video files here. And it would be hard for us to do single processing of that video file. So what we do in this case is we take the video and we create chunks of it. So we do about 2 to 5 minute chunks of this video file, and then we convert each of those smaller chunks into whatever format we want, and then we have another batch function which is going to combine all these chunks into one single video file. And then once we have the video ready, we are going to merge the audio and the video together and put it into our bucket, the destination bucket, which is ready to serve to customers. So one of the important aspects here, Julian, is since we can take advantage of parallel processing. Since we are creating chunks of video files, we don't need to serially do it and take a lot of time. So since it is parallelly executed, we have achieved the processing time which is of the same length of the video. Like if the video is 1 hour, we can pretty much do this conversion in 1 hour time. So that is why we call this real time media conversion. So that is the advantage here, where we are able to process things in parallel. If you look at the graph again, especially in the video conversion, we are creating chunks and converting them for each and every format. So in video, we are doing 33 different formats. So you can imagine how time consuming this could be. And in here, we are actually taking advantage of parallel execution. And
so when you say real time, it's taking 1 hour to do one video. It's actually taking 1 hour to convert 33 videos, or to convert the video into 33 separate formats. So that is, it may take an hour to do one, but you're doing 33 at a time, and that's what gives you the huge parallel processing. I do just have a question that's come in from Malkit Singh. Malkit, thank you for your question. How do you manage syncing audio and video after splitting it? I don't want to prompt you, but I think I'm going to guess and say that actually, because the video isn't changing, it's just different formats. And so actually splicing the video and audio together afterwards shouldn't be a problem, but I could be wrong.
Yeah, that's absolutely correct, Julian. Yeah. So I lost my train of thoughts. So that's where I want to end, and Sandy can take over and explain how we are orchestrating this whole setup using step functions, how we are using a step function to give some tasks to AWS batch, and using Lambda functions here and there, and so on. Over to you, Sandy.
Prashanth is going to still stick around. I'm just to make a bit of space, I'm going to just flip him off the side view, so he isn't staring at himself the whole time blankly. But he is around for questions. So if you have anything, we'll bring him back towards the end, and you can ask all your gnarly questions. Thanks, Prashanth. We'll see you shortly.
Yes, thank you, Julian.
Yeah, so this is the architecture diagram that we arrived at after some permutation combination. So before we dig into that, let me explain the services that we're using over here. So firstly, we're using Amazon S3 as the storage. So all the audio files and all the video files, the source files and the output files will be stored in the bucket. And then we have the VPC and the VPC endpoint. So basically, we're using EFS drive to share the data between lambdas and batch functions, and that's where EFS comes into picture. So it becomes one shared storage for all the instances to communicate to. And then we have lambdas, which we use to create the data set or to do the video conversions for all the chunks that we're creating. And then we have AWS batch. So batch basically you can basically create job and job definitions, and based on that you can probably run a container file or any other sort of system, and then execute that to do the conversion. Now why these selection of services is that a video conversion process is quite heavy. So a file, say, of 50 GB or 100 GB of length, that cannot be processed within Lambda because Lambda would time out. So that is where batch comes into picture. So using batch, we'll be able to do the heavy lifting, and using Lambdas, we'll be able to do the parallel processing. So with a combination of these two, we could achieve an ideal run rate. And then step function comes into the picture, where we need to orchestrate the entire set of events together in one single flow. So at the end, we can track one single file from its source to the destination, what are all the conversions that has happened, whether there's a failure, at what point there was a failure, at which chunk specifically the failure has happened. So that level of detail, all of it in one single execution. And that is where the step function stands out. And the ability to integrate services like batch and lambdas together is one of the key points for using step functions.
So that's a really good. I like that good point. So using step functions as the sort of big orchestrator to make sure that all the services work together. You can roll things back. You can do step functions is really good for doing decision trees, to do error checking. If something goes wrong, you can do something. But then use the power of batch to do the batch processing, and then combine that with the power of Lambda to do really have a single function that can be super locked down to what it can do. It's really easy to understand. command, really powerful, but you're able to parallelize it out to be able to take these huge video chunks. And also this is showing really how you can connect to a VPC as well. If you're using EFS, that does require a VPC connection. And so a lot of people are doing Lambda and they're thinking, well, the VPC connection is going to be hard. I don't understand networking. The cold starts are going to be terrible and whatever. And that simply isn't the case anymore. Lambda connecting to a VPC is really quick cold starts. That problem has been solved. And then you can use all the other VPC networking constructs to manage your traffic and to have VPC flow logs and to be able to decide what goes to the internet and be able to just manage your traffic in a really sort of enterprisey powerful way.
Yep. All right, so now digging further into the architecture diagram. So we have a Lambda call initiator. So this basically captures which is the video file that needs to be converted and probably into which format. And that is basically the starting point for the step function. Either it could be triggered manually or it can be tied up to an S3 trigger and triggered automatically. And then the next step is that it calls a batch function. So this batch, what it does is that it downloads the file from S3 onto the EFS storage and then splits the audio and video tracks. And then it splits the video into the respective chunks. So a chunk is basically a 2-minute portion of that video. And we have tried different lengths to see which would be the optimal chunk. So somewhere between 2 to 4 minutes is like an optimal chunks, where you could be able to achieve the faster processing and without compromising on time. So once it downloads the file, splits and stores it in the EFS, the batch function exits. Then it goes to data preparation Lambda. So this Lambda basically scans the EFS drive using a unique ID. So that ID will be passed on from the top level, and based on that we create the folders and the video chunks, right? And then in the data prep Lambda, it basically scans the EFS drive and creates the data set. Now, why it needs to create the data set, that we'll get into in the next point. Now, after the data preparation Lambda, we enter the parallel state of a step function. So basically, in a parallel state, we'll be able to run multiple branches of step function flows together. So in this case, it's just 2 items, that is the convert audio and the convert video. But in theory, you can have multiple items happening on each single branch. And over here on the left side, the convert audio is again a batch function, which converts the audio into 3 or 4 formats, because audio formats can be reused, but the video formats cannot, right? And then on the right side, we have the convert video. So here we're using a functionality of step function called as map. So what it does is that we pass an array to this function. And then based on the number of indexes in that array, it's going to spawn that many number of Lambda functions in this case, right? So in case you have a branch of items that you are having in this flow, that many number of branches would be invoked based on the data set that you're passing from the previous step. So once we're able to achieve this parallelization, all the video files, all the chunks into all the formats is converted at a single shot. So it doesn't wait for say the previous resolution to complete or the next resolution to complete. All the video files together are converted at the same time. Now the only limitation is that you can set a concurrency for the task item. So say you want to invoke only 100 lambdas at a single point. So if you want to do that, there's an option called max concurrency, and by setting that, you'll be able to limit that. And after all the conversion is done, so after all the conversion is done and both the steps are completed, we hit the next batch function. So this batch function basically combines all the video files together, creating the master video file, and then combines that with the audio to create one single output. And that output is again stored into the S3.
Excellent. We just got a question which has come in from Zach Jones Noel again. The chunk is a defined sized video and audio, question mark, or is that dynamic chunk size based on the original video? My guess it's a fixed chunk size. Is that correct?
Yeah, so we have tried with 2 minute, 3 minute, and 4 minute chunks. So you can experiment with any file size to see how much time your Lambda is taking to convert it. So in our case, for the full HD videos or the ultra HD videos, if it goes to say 4 minutes, the Lambda, I mean 4 minute chunks, the Lambda execution time increases a lot. So you need to play around with the chunk sizes and see what would be the optimal memory consumption and the execution time of your Lambda.
Okay, thank you. And then Sahil Kulkarni, welcome back, Sahil. Thank you for a question. Have you reached the map state input limit yet? And off the top of my head, I don't actually know the map state input limit yet. But I know it's pretty big. Well, it's pretty big, and I'm thinking, if you've got a 60-minute video and you're chunking every 2 minutes, that's only 30. That's only 30 inputs into the map state. So I suppose it depends how long the videos are.
Yeah.
So yeah,
and that is also where we set the concurrency, right?
Yes. So you okay? Yeah, because but then you setting the concurrency, that's after it's got to the map state, or
it is part of the map configuration.
Okay. Yeah. Excellent. So yeah, you've actually got control then over how many of the map states going to run at the same time.
Yep. Yep.
Okay, thank you. That's all the questions we've got for now. Please, if you've got any other questions, we'd be happy to hear them across. But yeah, carry on, Sandeep.
Yeah. Okay, so now let's move on to the AWS step function. So this is how the step function would look like. It's similar to the architecture diagram. So the same steps follow. You have the initiator, which is going to download the file, which is going to send the basic information telling what is the file, where is the file, what resolution you need to convert it to. And then you have the download and split step, which is basically going to download the file from S3 and store it onto the EFS, split the files and stuff. And then you have the data prep, which is going to scan the Lambda, scan the EFS and provide the data set. And then it goes into the parallel state, convert audio on the left, convert video on the right. So the convert audio is going to invoke another batch function, which is going to convert the audio into the respective formats. And then you have the convert video. So this is again, this is the dynamic parallel state that I was talking about, which is basically map. So based on the number of indexes in the array, is going to invoke that many number of steps. And then at the end, you have the final step, which is the consolidate audio video. This is another batch function, which is going to combine all these things together to provide the proper output.
Now, I'm going to say it yet again that sorry for interrupting, but quickly, I'm going to say it yet again, that architecture diagram that you were showing beforehand, I love it that step functions basically shows you that architecture diagram in the diagram when you build the step functions, and you can now use the new Workflow Studio to build this visually. But it's so great that you can share this workflow with anybody in your business. They need to know nothing about technology. As long as you've named your steps correctly, somebody can go, I understand what that's going to do. It's going to download and split the source. It's going to then convert the video. I can see it's in the map state and then consolidate. And that is brilliant. It's such a nice sort of shareable artifact and really helps people understand step functions.
Yeah, like you said, that's one of the major breakthroughs of using step function, is that it's very similar to the business logic, right? It's not completely a jargon. Like when a business guy sees it, he'll be able to understand at least on a certain level what is happening. That clarity would be there. So I think that is one of the key points where step function can be used to orchestrate the entire set of items, but at the same time, it is understandable by everybody else also. Yeah, so just basic definition statements. So here we have the start at. So this is where we say what is the first step that needs to be invoked in the step function. So in this case is the initiator. So in the states we have initiator. So this is like I said, just a basic Lambda. So here we're using type task and resource. We're providing the ARN of the Lambda function, and then we say what's the next step to be invoked, right? And then this is how we call a bash function. So over here, you can see the resource, we specify the generic ARN and provide a dot sync. So what dot sync does is that this step is going to wait until the batch job has completed its execution. And then these are the parameters you pass to it. So basically, to run a batch job, you need to provide a job name and then a definition and a queue. So basically, a definition is the place where you define what are all the commands it needs to run, and what are the other settings, like what is the Docker file or any kind of network settings that you want to give. And then you provide a queue onto which the job is going to run. And this queue is linked to your compute instance, and based on your compute calculations, you can shuffle around with these items. And in the job definition, you also provide how much memory and CPU consumption that specific job would require. And then you have the data prep. That is basically just another Lambda, just like how we have seen before. And this is the part where we step into the branches. Now, in the parallel path, we have two branches over here. So one of it is the convert audio, and the next part is the convert video. So in the convert audio, we're calling another batch job, similar to the one that we invoked before. And in our case, the only difference is the job definition and the job name. So we're using the same job queue, but on the definition, we're using different definitions to call different configuration files that is going to do the respective set of tasks. And then this is the map part that I was talking about. And over here, you provide an input path. So this basically, the items path points to the variable, which is going to have the array. So based on the number of items you have in $.files, is going to invoke that many number of states over here. And then you have the configuration to set the maximum concurrency. So in our case, it is set to 120. And after all that, we have the final consolidation lambda batch job, which is the configuration is similar to what I've shown before, except the job definition, the job name are different. And now to see the previous execution. Yeah. So this is one of the executed step functions. So here you can see the input to this step function is basically bucket name and a generator ID, what's the resolution, and what is the file name. And that would translate, the data would flow through all the other steps. And the main part, what I would like to show is the map part. So yeah. So as part of the data prep, what we do, when I say data prep, it's basically preparing this file structure based on the number of chunks. So in this case, it's 41 executions, which basically means it's 2 minute into, so it's an 80-minute video. So similarly, based on the number of, based on the length of the video, the number of chunks would increase or decrease, and based on that, the array would get formulated. And then we are also passing the resolution that it needs, and either we can configure it as part of the main source input, that this is the resolution it needs to convert, or you can have multiple parallel states, one for each resolution, and convert all of them together. And what happens over here is that once you click on this map after it is executed, you can see the number of indexes. So this the array had 41 indexes, and similarly we have 41 indexes over here. And by clicking on, say, any of the index, you'll be able to see what input was provided for that index, and then what is the output. So this level of information is possible via step function. So without step function, if we were using, say, an SNS fan out or any other mechanism, we would need to have, we would need to keep track of all the things that are happening between each chunks, and then we will have to stitch the data together. But by using a step function, you can orchestrate all of them together and get one single execution. And this is what I meant by one single execution, right? You have one execution ID that keeps track of your entire video file from the source to the destination, what are all the data points, what was the input, what was the output, how the parallelization has happened, and whether there's any failure. And then at the end, you have the batch job, which is going to convert both, which is going to consolidate the video file and the audio file and send it back to Sri. And just a glimpse of batch job. Let me just show you some of the jobs that has run. So these are the 3 jobs, like the ones that I've showed in the step function. And let's say any one of them. So basically what we do over here is pass the commands. So we have written Python scripts to do each task, to do the consolidation, video splitting, and all these things. And based on the respective job definition, we have different commands that we run. So in this case, it's consolidate.py, which is going to consolidate the audio, video, and then upload it back to S3. So yeah.
Excellent. Thank you very much. We did Zach Jones again, talking back as we were talking before about the concurrency limit. Based on the video, say 500 chunks are created with the step function, handle it or error up when that concurrency limit is exhausted. So concurrency limit set to 120. If you've got more than 120, how does the step functions execution handle that?
Okay, so the task type is going to wait for that 120 executions to complete. Either all of them are succeeded or one of them fails and the entire process stops. So considering this success scenario, it's going to wait until 120 executions are complete. After that, it's going to invoke the next set of 120 invocations.
Yeah, no, that's exactly how it works. It's not going to error back to the front. It's just it's just a queuing mechanism that it's going to do 120 at a time, and it's just going to then iterate through the queue until they are all finished. One other question I had, you were talking about the happy path all working well. What happens if one of the media conversions fails, or because I see within your step functions workflow here, you don't have a lot of error checking. So is that then handled in batch, or how are you thinking about error checking?
Yeah, so there are two ways to handle it. Either we can handle it as part of the batch jobs, which is one of the things that we have done. So as part of the Python files, when something fails, we capture that error and remove the partly created video files or audio files. So we basically clean up the system so that no other error comes into it. And the other way to do it, which is not shown over here, is to capture the error using error handler Lambda. So we can configure retries and failure mechanisms for each step. So as part of retry, we can probably retry it a couple of times just to make sure it's not syntax error or something. And then based on the error type, we can branch it out to a separate failure handling Lambda, and that Lambda is going to be invoked when there's a failure in the step function, and that is going to when that is invoked, we also get the error what has happened, and based on that you can take a custom action.
Okay, so where would that custom action then be stored? So if something happens within the batch, the step functions isn't going to really know. The step functions is just going to assume that individual video file is created successfully, I presume. So what's your sort of notification path for knowing that it's now missing a file?
Okay, so when there's an error in the batch job, so that basically means there's an error in the Python file. So in those kinds of scenarios, we just use a try and except block and then cache the error and take the respective action within the batch job. Now apart from that, if you're having an error in the step function, then you can have a retry mechanism, or you can have a failure handling Lambda, which is going to detect what the error was and take the action accordingly. So say if, for example, in the data prep Lambda, so we have a file of say 40 minutes. So we know that there are going to be 20 chunks. But then when we are scanning the EFS drive, there are only say 19 chunks, which means one video file is missing, right? So in those cases, we can raise an exception, and then it's going to stop the step function from proceeding forward, and is going to route it to the failure handling Lambda. So that Lambda is going to either retry the entire mechanism or remove the files that are there.
Excellent. Yes, I mean that gives you really the point about this is to have the orchestration out of your Lambda function code as well, where you can. Obviously, within the batch jobs, you're going to have some error handling within the Python scripts that are in the batch things, but external to that, to the step functions, you're going to want to try and build your error handling into the step functions itself. For a number of reasons, you don't have to handle some of the retries and the limits or that. You don't need to do a Lambda function. It's going to do that. Step functions can handle that for you, and also it's visually really nice nice. This all looks all green. If there was an error, you would see it literally in red, and you'd be able to trace it through looking at the step input and the step output and see exactly what happened. So it makes it a really visual way, and it's a far easier way to troubleshoot it rather than diving in some deep diving in some log groups.
Yep. And also, as part of the workflow builder, when we add a step using the workflow builder, it automatically adds the retry and catch block statements into the definition. So that is one of the advantages. Now that we don't have to do it separately, like as soon as we drag and drop an item, it's an automatic feature.
Yeah, that's I really like that part of the workflow builder, that some of the best practices for building this are built into the tool, so you're not just sort of left alone. Well, off you go where you're going to create it. And yeah, as you drag things onto the canvas to build your step functions workflow, it's going to add some other things to help you build a better state machine. I don't have any other specific questions that have come in yet. If you do have any, please, we'd love to hear from you. One other thing from me is in the sort of convert video batch mechanism. Obviously, you must have thought about some other ways. You could have used a Lambda function. You could have used maybe a nested state machine within the bigger state machine. I understand using the batch for the download and split because a Lambda function doesn't have you need some more storage space and you need more than 15 minutes. So definitely you need something that Lambda can't do to do that. But if all the files can be processed in under 15 minutes, what was your thought process of using batch for the convert video, and the advantages and things that made you think that for that specific reason it was a great idea?
Yeah. So if we were to use AWS batch to convert the video itself, that is actually a time-consuming process. So, at the time, a batch would take time to convert one entire video, let's say a 1 hour video. You could probably convert 2 or 3 resolutions of that using the dynamic parallelism and lambdas. So that is where the trade-off happens. Speed versus what you can do with the lambda, right? But in case of convert audio, you cannot split it and then convert it because combining the audio together, stitching it together becomes a problem. So audio is kind of very sensitive on that. But when it comes to video, you can round it off to the next frame. So say 2-minute chunk, but round it off to the next frame. Then when you join it back together, you have a perfect video. But that's kind of tricky to do in audio. These are some of the reasons why the video conversion happens in Lambda, because you can cleanly split it and convert it together. And this is the more this is the part that takes more time, right? And when you are able to do it together for all the resolutions, you achieve the real-time conversion.
Excellent. Yep, that makes complete sense. And also, when you're converting the video, the files are going to converting the audio, the files are going to be much smaller. So you're not bumping up against any kind of limits that you don't really need to split because you're only splitting the video files to be able to handle the size and also do some parallelism. But yeah, converting audio is going to be a much quicker process. Excellent. Sandeep, is there anything more you'd like to show us from this, or any other sort of future things you're thinking about? Or yeah, what else would you like to tell us about your cool state machine?
Yeah, so one of the things that we could do that we have not added yet is probably another storage layer like a DynamoDB, just to keep a record of whatever has happened. So right now it's just directly taking the file, converting it and putting it back. But that's one of the things that you can do to make sure you have proper track of everything that is happening.
But that's interesting, actually, because I like this kind of approach. And what also James showed last week is you're not actually having to maintain a map of all the chunks in something like DynamoDB and having to remember which is the start time and the end time and storing that, and then having to pull DynamoDB to get the next time sequence to do that. This is all. You don't need any central storage for the coordination. You need central storage to store the video files, but you don't need a database or something to track all the processes that is going through. So I do like your approach over there, but I do see there's more functionality that you may want to do.
Yep.
Excellent. Anything else, or should we bring back Prashanth and he can let us know some other things on his mind?
Yeah, that's pretty much it. Like we can bring back Prashant.
Excellent. So yeah, Prashanth, when you do pop up, I see he's over here. We'll add you to the stream. So Prashanth, I don't want to do a live performance review for Sandeep on the screen because that would be that would be rude. But I think he's done a great job showing how you can use step functions, and I very much like the integration with things like batch, integration with VPC, and all these kind of things. So that's the power of step functions, is being able to connect to other kind of things from a networking construct with VPC, but also you can use batch, you can use containers, you can use Lambda.
So another interesting thing about step function is the normal step function, not the express one, is it can hold the state for 1 year. So, that's a really, really long time. Pretty much you can do a lot of different kind of workflows, which can span very, very long time. And you can always come back and resume the processing from wherever you left off. That's very, very interesting. And there are so many things you can achieve with that. Without we can pretty much do a lot of kind of workflows which needs approvals and stuff like that without even having a database backing the data and so on, because step function is going to hold that for you. So there are a lot of interesting cool things you can achieve in step functions.
Yeah, definitely. Just picking on some of those things is like the return path that, you've done a whole bunch of stuff with step functions, and what you want to do is just grab what it received at the beginning, because obviously as your workflow goes through step functions, it's going to have input and output. That's all going to change. And what you can do is you can re-add information from previous steps, which may be then useful for a future step. So that is super useful. And then there was another one I thought of at the top of my head. It's gone out of my head. I'll wake up in a cold sweat tomorrow morning thinking about it, or I will remember lately. I'll remember shortly. Oh, that's annoying. I can't think of it. But anyway, carry on, Prashanth. You were talking about other cool things for step functions.
Yeah, I mean, also you can achieve a lot of different microservices patterns in step functions as well. Like if you want to do a circuit breaker, you can do that. You can do different kind of error handling. Like generally you have a single way of doing error handling, but in step functions you can actually handle different errors differently. Like if it is a rate limiting error, you can handle it in a different way. You can branch out and granularly tweak your workflow for each of those different outcomes from the previous step. That I really, really love that aspect. And it's definitely something which is very, very powerful, which lets us achieve a lot of different architectural patterns.
Excellent. Yeah, the one other thing I was thinking of, I had thought about it, is, as you said, step functions, standard workflows can run for up to a year. But what a really powerful thing is the task token. What you can do is you can basically pause a step function workflow, and then you can wait for a human approval. I mean, this could be anything, or any kind of thing that a human needs to do. And then what you can do is you can send that task token back to the step function saying, my human approval is done. I've got permission to do this, or I needed to check something else, or I needed to send something via fax machine. It could be as old as that, who knows? But yeah, you can then talk back to the step function and say, yep, I'm ready to continue. Off you go, and the step functions will resume. So that's a really powerful way that we talk a lot about orchestration, and it can all be automated, but you can also bring some a human touch into it, and some pausing the workflows, waiting on other kind of things. We do have actually some questions coming in. I'm not sure if you know, but it's talking about how step functions connects to API gateway. And Mozart 409, thank you for joining us and your question. But if I invoke step functions from API gateway, how do I return the result to the end user through the API gateway? Now, I'm a bit vague on that answer as well, so please apologize to me. But we did have Zach Jones Noel, thank you again. It says you can do that with express step functions, but the API can time out. So either of you, do you have a complementary or better or worse answer? If you don't, that's fine as well. I'll have to look it up.
I was going to defer to that answer as well. Sandy, if you have anything else.
Yeah, so it's the same answer, but just a little more detailed. So express step function basically has two different types. You have the synchronous and the asynchronous. So by using the synchronous version of it, you can directly link an API gateway to the step function and get the response out of it.
So I suppose, yeah, I don't know, maybe there's needs more detail, but how do I return the result to the end user through the API gateway? I presume that's just the API gateway response that's going to come via the integration response, and a normal response is if you're calling a REST API. Okay, excellent. Thank you very much. There was something else. There we go. Well, that's sort of all that I did want to mention that as well. Can be configured within Step Functions directly to API Gateway instead of to Lambda, and that's in the console within your Amazon states definition. So Charishil 1, if you're from the Step Functions team, I'm not directly, but I work within the bigger org, so I'll take that. I would like them to restart from the last failure point, at least a configuration to allow that. I do like that idea. I will certainly pass that on to the product management team. Yes, but with all kind of things, they are always super happy to hear customer feedback and to add some different configurations or features or that kind of thing. So I will stick that on my sheet. We have regular feedbacks with a lot of the serverless product teams, and so this will certainly go into our request list, and I will mention that you had asked. So our time is sort of coming to an end. Prashanth and Sandeep, is anything more you'd like to add?
Nothing much, nothing else, Julian. It was really nice being here talking about serverless with you. Really enjoyed.
Thank you very much. Thank you for joining and taking the time to do a cool demo. And this is one of those nice things with Step Functions, is you can also visually see things, so you can picture what you're talking about, and it's not a sort of necessarily about a whole bunch of code that's difficult to understand. So I certainly understood the demo and what you were doing and why you did your particular choices. So yeah, thank you for putting together something really good. So yeah, that's it for Serverless Office Hours this week. But next week, it is actually what we've just been talking about on the 21st API Gateway. Eric Johnson's going to be your host, and I'm not actually allowed to tell you. I begged Eric to let me know what was going to come up. He did whisper what is happening, but he's going to have a cool demo to show you, but he can't let you know yet. So sorry, what you're going to do, you're just going to have to join next week and see what Eric has in store for you. Always remember, I think we've got a sort of 5-week schedule that we go through, and we cover API Gateway, we cover Lambda, we cover messaging, which is Event Bridge, could be Kinesis, could be MSK, all those kind of things. I've already lost my track of what the other one was. Lambda. We've got Serverless Surprise, which is another one, which you bring in various different kind of things. It's definitely another week which I've forgotten about, but sorry about that who I've missed. But yeah, there's a whole rota. So we literally try and cover everything we can to do with serverless technologies here at AWS. As I said, we live every week, so you can get your questions answered as you saw this week. So yeah, if you've got burning questions for our guests as well, they always appreciate to hear from you. Just finally to wrap up, everything you want to know about serverless on AWS, please head over to serverlessland.com. We aggregate all the blogs that get posted on a number of different blog platforms here at AWS. We've got a whole bunch of videos. There are learning paths and there are training videos, and there are serverless office hours every week which get posted up to YouTube. We've got some learning pathways. We've got various ones that have been done. I've done one on observability, which you can have a look at. AWS Lambda extensions. We have one on, what's another learning path? Getting started with serverless. James Bezik's done one on Kinesis and data streaming. So there's a whole bunch of stuff over here. Serverless patterns, you want to get those little snippets, head over to Serverless Land. So your one-stop shop for all things serverless.com. Serverless at AWS, please head over there. So yeah, thank you very much. It's not just me who's appreciative and grateful. Malkit, thank you, Prashanth and Sandeep, for the nice talk. Really appreciate you taking the time out today, as I said before. And yeah, thank you so much. And thank you to everybody who's been watching. There's another talk coming up on the AWS Twitch channel directly after this, so I don't want to bump into their time. So thank you very much. Enjoy the rest of your day and week, wherever you are, and we will see you next week. Thank you very much. Bye-bye.
Thank you, everyone. Bye.